Hello all, welcome back to my YouTube channel. In this video, I am going to solve the problem detect an intersection point in a linked list. So the problem statement says that we are given a linked list and we are given two pointers like head 1 and head 2. So what we need to find out that there is some intersection point at after traversal of some nodes. As you can see, 4 is the intersection point of these two linked lists, because at 4 they after 4 they are going to be common. So there are various approaches for doing this problem. The first one approach, as you can see, is the hash approach. What you can do is, but hash approach is going to take order of n time, and you are going to use a space order of n, which is largest link size of the largest linked list. So this approach takes time order of n time, and space is also order of n. So what we are going to do is, we would traverse the one of the linked list completely. We will traverse one of the linked list completely and store in the hash set. Store in our hash set. Create an empty hash set and store it like 1, 2, 3, 4, 5, and 6. Now we have pointed to the second node, second list. So what we'll do is we will start traversing. We will check is 7 is already present in the our hash set or not present. Okay, if 8 is already present or not present, then iterate to the next node. Is 4 already present? As you can see, 4 is already present. It means that you are visiting it twice. So that was the node which has already visited, and so you can return it like it is the intersection point of the node. And the second approach, which is key calculating the length of the linked list. What you can do is, see, for example, what will we will calculate the length of both, like calculate the length of both of the linked list. How? We are going to we are going to calculate the head one. Let us say it is the head 1, head 2. So now what we'll do is we'll calculate the length of the linked list of the first from the head pointer of first. Let us say it is the length 1 or A, and we will be calculating the length 2, which would be from pointer length second, which is, let us say it is B. Now what do you do is find out the absolute difference. Let us say here the length would be 1, 2, 3, 4, 5, 6. It is equals to 6. 1, 2, 3, 4, 5, and this would be 5. So this length is, this list, the first list is larger than the second one. So we are going to get the difference of 1. So what we'll do is, the list which is larger than the second will move the pointer by that. So what I mean is, I will move this pointer head 1. So now as you can see is, the head 1 and head 2 are at the same distance from the intersection point. Now what you do is you keep moving one pointers ahead, one pointers ahead, both head 2. Now at a certain point they are going to meet, and this is the condition which we want to say that there is intersection here. Head 1 and head 2 are both meeting, so we can say that the intersection is here. Now this approach takes, we need to traverse this linked list once by calculating length of 1, and again by calculating length of 1. So order of n traversal, plus after calculating, we might go to the intersection point, which would be either at the half or at the end of the linked list. So it is order of n. And space complexity, we are not using any extra space, we are just using two variables. So order of 1 is the space. Now there is one more solution to it. We can think of is like, let me draw a linked list first. 1, 2, 3, 4. Let us say this was our original linked list. Now we want to calculate the intersection point. So the third approach is two pointer approach. The idea behind is like we are going to have head 1 and we are having head 2. So we'll create two temporary pointers, n1 and n2. So what we'll do is we will start traversing. And in the question, if anyone of suppose n1 equals to null or n2 equals to null, anyone is in the beginning is itself null, then there is no intersection point. We just have to return. We don't have to do find intersection, because in that case there would be no intersection point. Now what we are going to do is we are going to move n1 by 1 and n2 by 1. So what we'll do here is n1 and n2. As you can see is the length of the linked list 2 is smaller, so n2 will reach to the null. Let us say it is null here, I forgot to point out. N2 will reach to null faster because it is moving one pointer ahead. So n2 n1 will be here and n2 will be here, n1 will be here and n2 will be here, n1 will be here and n2 will be here. So n2 will be here and n1 will be here. As you can see, n2 reaches the null first. So what we'll do is when n2 reaches null, you just make it point to the head of 1. You just change it to head of 1 and again iterate it, iterate it. So after this, n1 will be here and n2 will be here and n1 will be null. Now n1 is null, so make it point to the head 2. Now again, as you can see, they are at the same distance. Now when you move one pointer ahead, they are just going to be n2 and n1. Now they would be at n1, n2 and n1. So they are going to meet at some point. Then that point is called as intersection points. So what we are doing is we are iterating over the both of the linked lists until we find an intersection point, or we reach until we find an intersection point, or if if one of the pointer reaches to null, what we will do is we make it point to the other's head. And if similarly, if others pointers reaches to null, we may make it to the pointer of head node. So this is the approach behind it.